exercise combined together because they basically talk about the same thing. They're all trying to solve for simultaneous linear equation, and it's by two different methods. One method is called substitution. So the left-hand side box is done by substitution method, and the right-hand side is done by elimination. So I'll explain those two methods. So first of all, what is simultaneous equations? Well, we do linear simultaneous equations in this exercise because all talk about linear. So again, linear is the variable with power of 1. Okay, linear is the variable with power of 1. Well, we don't have like square, something like that. And then we have two variables, okay, in this equation. We have two variables, x and y. Well, we can use a and b, c and d as well. Then we have two equations to solve for two variables. Okay, we have two equations to solve for two variables. Okay, how many variables you have? You need to at least have this many of equations. For example, you have 3 variables, then you need 3 equations to solve for it. If you have 2 variables, then you need 2 equations to solve for it. Well, the easiest one is like what I show here. So we have x and y with 2 variables, and then we solve that simultaneously. So 2x minus 3y equals to 5, and y equals to 5 minus x. If we think about that, so we want a pair of x and y value to give you, to make those two equations true. Okay, we want one pair of x and y to make those two equations true. So the x in both equations means the same number, and the y in both equations will represent the same number. So they are the same thing for x and y. I'll talk about that's the numerical meaning, okay, algebraic. So if we do the calculation, that means the same pair of x and y value will make both equations true. So because the y is the same y, okay, in both equations, we can replace that y by 5 minus x in the first one. This is the method called substitution. So if I name the equation, that's equation number 1, and the second one is equation number 2 with 1 and 2 there. Okay, substitution. This method is you make x or y to be the subject. Okay, you need x or y to be the subject, and you substitute this into the other equation. Okay, you substitute that into the other equation. So what we have here is y equals to 5 minus x. We already have it. Okay, we already have it. That's y to be the subject. Now I can put the whole equation into the first one to replace y. So what I can say is sub equation number 2 into equation number 1. Okay, we sub equation number 2 into equation number 1. What equation 2 tells us is y is equivalent to 5 minus x. Y is equivalent to 5 minus x. So for the first equation, it tells us 2x minus 3y. So y is equivalent to 5 minus x. I can replace y by that. And then this equation will still be true. So why I'm doing this? I have replaced y by x. Now in this equation, we only have variable x. Then we can solve like a linear equation. Okay, we can solve normally as a linear equation. So I don't want 2 variables in one equation. I can't solve. So I need to replace one by the other one. Okay, I can replace that by the other one. So that's what we have. We can expand that. So 2x minus 15 plus 3x, that equals to 5. So 5x equals to 20. I can add 15 on both sides. So add 15 on both sides. So what I have is 5x equals to 20. Okay, after you add 15 on both sides, you have 5x equals to 20. And then x will be 4. X will be 4 because you divide 5 on both sides of the equation. Okay, we divide by 5. Okay, it's not enough to only solve out x because you have two variables. Remember, simultaneous equation, you need to give both values. Okay, you need to give both values. So therefore, y equals to, well, I can use any equation to find y, but obviously the second one is much easier because it's y equals to 5 minus x. So x is 4 now, so 5 minus 4, and then y equals to 1. So my two answer will be x equals to 4 and y equals to 1. But you don't really need to write it into the test. Well, that's kind of help yourself to know what you're doing, but it's not necessary. But for me, like, I still keep this habit to write like what I'm doing. So if I feel like any step I'm going wrong, I can go back to change it. But it's not necessary. It's not like looking for marks. Yeah. Okay, this is the method called substitution. So substitution is replace something by another thing, right? So we replace y by x in this question. So we need to make y in terms of x and then replace it in the first equation. So we put the second one into the first one. That's substitution. Okay, when we do elimination, the two equations must be in the form of ax plus by equals to d form. Remember, that's the other form of the linear equation, ax plus by equals to d. We must put both equations into that form, okay, into that form, and then we think about elimination. So let's do this one first. So the first equation gives us 2x minus 3y equals to 5. Well, I don't need to change this. It's already in the ax plus by equals to d form. But the second one is not. So what second one gives me is x plus y equals to 5. I can plus x on both sides. Okay, plus x on both sides to make x plus y equals to 5. Okay, that's the two equations we have now. Okay, this is still equation number 1. I can give a new name that refers to equation number 3. Okay, a new name to equation number 3. What I'm trying to do here is, well, after this is the first step. Okay, this is the step number 1. So step 1. Okay, what's step 2? Step 2 is I want same number of x or y in both equations. Well, I want either you have the same number of x or you have the same number of y. Okay, either you have the same number of x or you have the same number of y. Well, ignore the sign. Plus or minus doesn't matter, just ignore the sign. Okay, if I want to have same number of x, what I can do? Well, how many x I have in the first equation? How many I have in the second one? 1 only, right? So I want a common number. So what can be the common number? 2 can be the common number. Well, I mean, I want to make same number of x. So 1x is easy to become 2x, right? 1x is easy to become 2x. Let's look at the y. So I have 3y. How many y I have? 1y. So 1y can become 3y as well by times by 3. Okay, 1x can become to 2x by times by 2. Well, I can change any. Okay, I can change any. I can change the same number of x, or I can change the same number of y. Well, this one I decide to make into y. It doesn't really matter. Okay, it doesn't really matter. I will show you both methods. I can. Oh, let's change y first. Okay, let's change y first. I have 1y in the first one. I want 3y. So I will times equation number 3 by 3. Okay, times equation 3, both sides by 3. Okay, y times both sides. I still want the same equation. I want to that still be true. So what I will have is 3x plus 3y equals to 15. Times both sides by 3. Okay, times both sides by 3. So every term needs to be times by 3. This is like, well, a new equation number 4 now. So I will copy this equation down here. Okay, that's my equation number 1. Okay, now that's my new 2 equation here. Okay, see, we have the same number of y now. I want to eliminate that. Okay, I want to get rid of it. I want to get rid of it. I can add 2 function or I can subtract 2 function. Okay, I want to eliminate that. Do you think if I add 2 function, y will disappear, or I subtract 2 function, y will disappear? Do you think I add 2 function, y will disappear, or I subtract it, y will disappear? Add is a plus 3y and a minus 3y, so I will add. So the step 3 will be, if they are at the same sign, what we'll do is subtract. If they are at a different sign, we will add them. We'll add 2 function. Okay, we'll add 2 function. If they are at the same sign, we'll subtract 2 function. If they are at the different sign, then we will add 2 function. Okay, look at the same number, like the same number. So we have y, so we look at y. So when I add 2 function, you add equation 1 and equation 4. Okay, think about the add. So 3x add 2x, what do you have? 3x add 2x. 5x. Good. So we have 5x. Minus 3y add 3y. You have 0. So we have 0, nothing here. Equals to 15 add 5. 20. Okay, so we have eliminate y by add or subtract 2 function. The y will disappear. So the purpose is still get rid of 1 variable. Okay, get rid of 1 variable. Still remain 1 variable in the equation. So my x equals to 4. So my x equals to 4. And my y still equals to 5 minus x. So it's 5 minus 4. And y equals to 1. Okay, y equals to 1. Okay, let's have a look at the other way, like to change x. Well, this time I have changed y, right? This time I've changed y by times the second equation by both sides by 3. But I can change it to same number of x as well. So if I was to change it to same number of x, I will times equation number 3 by 2. I can only times or divide, okay? I can't add or subtract. I can't say, oh, I add 1x on both sides. That's not working. If I add 1x on both sides, then the other side will have 1x out. Okay, the other side will get 1 new x. That's what I don't want. So I can only times or divide the number, okay? So if equation number 3 times by 2, what I will have is 2x plus 2y equals to 10. Okay, that's the new equation number 4. And don't forget, I still have my first equation, which is here. So now these 2 are my new equation. That's still equation number 1. Okay, in this case, should I subtract or add 2 function? Subtract, because you have 2x and 2x in both equations. They have the same sign. We should subtract. Well, I can simply use the top one, subtract the bottom one. Or you can use 1 subtract 4, but it's a little bit hard. Because it's really, visually you can see is the top one subtract the bottom one. Let's think about 2x minus 2x, what that equals to. 0. What's 2y minus negative 3y? 5y. Okay, it's not addition. It's 2y subtract negative 3y. So it's a 5y here. Okay, it's the top one minus the negative 3y here. And what's 10 minus 5? 5. So in this time we solve y first. Y equals to 1. Okay, y equals to 1. And then according to the second equation, 1 will equals to 5 minus x. Then x equals to 4. Okay, x equals to 4. All right. Okay, that's the two method. Okay, that's the two method. Let's have a look at the second question here. Okay, let's look at the second question. Do you think this question is easy to do by substitution or elimination? Elimination, because it's already in the form of ax plus by equals to d form. Okay, it's already get this form for you. Let's name this equation. We say this is equation number 1 and this is equation number 2. Let's have a think. How I can make the same number of x or same number of y? Common multiple. So if we want to change x, what's the common multiple should be? 15. Okay, 15. So if we want the common multiple, well, we may take the lowest common multiple. It's easier to do. So the first equation needs to be times by what? 3. Good. Times by 3. So we have 15x plus, well, everything needs to be times by 3. So 21y and equals to 3. Okay, don't forget the constant. The constant needs to be times by 3 as well. And then name that as equation number 4. Oh, 3. Well, it doesn't really matter. I can name the second one by 3. Second equation needs to be times by what? 5. Okay, times by 5. So I will have 15x as well, but plus 25y equals to minus 5. That's equation number 4. Okay, question is, should I add them or subtract them? Subtract. Because we have the same number of x. Okay, 15 and 15, same sign. Okay, same sign. Okay, when I subtract it, well, I just simply use the top one, subtract the bottom one. So the top one is 15, 15 becomes 0, and 21y subtract 25y, what do you get? Negative 4y, good. And what's the constant should be? What's the constant should be? 8. 3 minus negative 5. Okay, 3 minus negative 5, you have 8. Okay, we have 8 here. Y equals to negative 2 then. Okay, y equals to negative 2 then. Okay, y is negative 2. We can solve for x. So we will say, well, I can use any equation to find x. So I'll sub y equals to negative 2 into, well, I'll just choose the easy one, like equation 1. Okay, just choose the first one, equation 1. What we'll get is 5x plus 7 times minus 2 equals to 1. Okay, just put the y value you solve out into any equation. Okay, not necessarily 1. You can put in 3 and 4 as well. But I choose the simpler one. So 5x minus 14 equals to 1. Add 14 on both sides. 5x equals to 15. And x equals to 3. X equals to 3. Any questions about this? Any question? Well, I always see students like doing tests and they always forget to solve one variable. After they solve out x, they say, yeah, good, we're done. And then just forget about y. So that's a common error. It's not really because you don't understand. It's just careless mistakes. So make sure it's simultaneous equation. You need to solve both x and y. Okay, both x and y. You need to list both values out. All right, well, you can try the substitution by yourself later. I'm not going to show that with you. Well, you basically need to make one thing to be the subject if you want to do substitution. For example, I will make the, I'll do the first step with you. So I will say rearrange. Well, I want to make x to be the subject or y to be the subject. I will rearrange number one. Not really change anything, just rearrange it. I'll rearrange first one. I'll make one thing to be the subject. Well, it depends on what I make to the subject. I can make x or y to be the subject. So I decide to make y to be the subject this time. So what I will have is 7y equals to minus 5x plus 1. I will subtract 5 on both sides of the equation. And then y equals to minus 5x plus 1 divided by 7. I'll say that's number 3. Okay, I have changed the first one to make y to be the subject. Okay, I have changed the first one to make y to be the subject. And then I will sub number 3 into number 2. You can't sub 3 into number 1 because they are the same thing. You just make it from 1. Okay, you make 3 from 1. So you can't substitute back into the same equation. But we can sub into the second one. So sub into the second one. Y is minus 5x plus 1 over 7. So 3x plus 5y, right? 5 minus 5x plus 1 over 7 equals to negative 1. Well, it's much complex compared to the other method. Now this equation only has x involved. We can get rid of the denominator, expand it, make x on one side, constant on the other side, and so forth. That's how we solve like a normal linear equation. Okay, a normal linear equation. I'm not going to continue from that, but that's how you should do for substitution. Okay, how you should work on this for substitution method. Let's have a look at the next one here. What method do you think will be easier for this one? Substitution. What do you want to substitute? Well, if I say that's equation 1, that's equation 2, what do you actually want to substitute? Do you want to replace x by by? Is there any other method, well, easier way I can substitute? Well, x is by is x as well. Okay, x is by is x. Let's observe the first equation. Replace the by x. We can do that as well. Okay, replace the by x. Replace two things by one thing. That's much easier. Instead of replace, well, you can replace x by by, nothing wrong with it, but just which one is easier. So we can sub 2 into 1. That's by substitution. Okay, that's by substitution. We can sub 2 into 1. So what I will have is ax plus x equals to b. We replace this by the x. How I should solve for x? What I can do next step? We have 2x now. How I can only have 1x? Factorize. So if I take x as common factor, what I will have here? A plus 1, good, equals to b. this is the coefficient now. Okay, a plus 1 is the coefficient. So what x equals to? B over a plus 1. Okay, it's b over the coefficient. So that's x. That's x. And let's look at y. So we can sub this into the second equation. So b over a plus 1 equals to b times y. So what y equals to? How I can solve for y? So, well, I'll write in the other way. by equals to x, so it's b over a plus 1. Okay. I want 1b. Okay, I want b. So what I should divide? I want y on one side. What I should divide? B. I need to divide b on both sides, right? Divide b is equivalent to times by what? Divide b is same as times by 1 over b. Okay, what the reciprocal? Okay, 1 over b. So what I can do is I can times 1 over b on both sides. Because it's hard to do division, so it's easy to do by times. So I'll times 1 over b. So y equals to this b and this b get cancelled is 1 over a plus 1. 1 over a plus 1. Alright, let's think about elimination as well. That's it. Well, x is b over a plus 1 and y is 1 over a plus 1. Yeah. Just that's it. That's all of it. That's the answer. Final answer. That's the final answer. X and y. I get my x and y. Well, we treat a and b as constant. We treat a and b as number, so we don't solve for a and b. We solve for x and y. Well, if we think about the elimination, we need to have ax plus by equals to d form. So the first equation is already in that form. Ax plus by equals to b. What I can write for the second one? How the second one can become ax plus by equals to d form? X minus by equals to 0. We can subtract by on both sides to make it into the right form. Okay, ax plus by equals to d, x minus by equals to 0. So they are in the correct form now. Do we have the same number of x or same number of y? Yes, we have by, right? We have same number of y. Should we add it or subtract it? Add. By got different sign. Okay, one plus sign, one minus sign. We'll add between them. What's ax plus x? Yeah, so, well, if we don't know what to do, we can just write ax plus x. That's how we add those two. by and by disappeared. And what we have here is equals to b. Okay, equals to b. Again, it back to the, like, that side is exactly the same as that line. Everything will be done by the same way. Okay? Like, it's back to that line. X plus x equals to b, x plus x equals to b. Everything will be done by the same method after that line. So it can be done by elimination as well. We just have the same number of y. Okay, we just have the same number of y. Alright, let's go to the next page. Okay, one two linear equation. Well, this is the graphical meaning of simultaneous equation. Okay, by graph. If we think about the graphical meaning of this simultaneous equation, what we all have here is linear equation, right? It's linear relations. We can all sketch for it, right? We can all sketch for the two lines. We can sketch for two linear. The solution, the answer, is the intersection. Okay, solution is equivalent to the point of intersection. The value we solve, for example, this one, 2x minus 3y equals to 5, y equals to 5 minus x. Those two equations, if you sketch for those two equations, okay, 5 minus x looks like that, and 2x minus 3y 5, we have that line. The intersection will give you 4, 1. The intersection will be 4, 1. So if you think of the graphical meaning, you will have intersections for those two solutions. Well, that's actually one pair of coordinates. Okay, one pair of coordinates. Let's have a think. Well, let's ask you a question. Do you think two lines will always intersect at one point? In which case it's not going to intersect? Well, to say written the same, what kind of lines then? Parallel lines. If you have two parallel lines, there's no intersection between two lines, right? Which means I can't solve out any value, right? There's no intersection. If there's no intersection on the graph, which means the simultaneous equation will have no solution as well. Is that true? If you think about that, we sketch two linear, we solve them simultaneously. The value we solve out should be the intersection of those two linear, okay, on both linear. But if two linear are parallel linear, okay, parallel linear, we can't have any intersection, okay, there's no intersection, which means there's no solution for that as well. How do you test whether two linear are parallel or not? How do you test two linear are parallel or not? If they have the same gradient, then the two linear will be parallel. If they don't have the same gradient, two linear will not be parallel. If two linear are not parallel, which means they will have intersection, right? If two lines are not parallel, they will definitely intersect once. But if they are parallel, there's no intersection. So, for example 1, it says, for what value of k will this pair of simultaneous equations have no solution? Okay, have no solution. No solution means they are parallel lines. And then further means they have the same gradient. Okay, means they have the same gradient. So if we think this one, they have the same gradient is 1 minus 4 equals to k. They have the same gradient, which means k equals to minus 4. Okay. If k equals to minus 4, then they have the same gradient, then they are parallel, and then they have no intersection. Therefore, there's no answer for the simultaneous equation. No solution for the simultaneous equation. Okay, gradient is y equals to mx plus c. Okay, mx plus c, then the gradient is m. Okay, gradient is m. So they have the same gradient is when k equals to minus 4. Okay, next question. For the second equation, the gradient is 4. But what's the gradient for the first equation? What's the gradient for the first equation? What we should do? Let's say what we should do to find the gradient. So for y. Yep, so for y. So we have this equation here now. What I can do is kx minus k equals to 3y. I move everything to one side. I move the 3y to right hand side and I move the k to the other side. And then I can divide 3 on both sides. Because I want y. I want to solve for y. I need to divide 3 on both sides. So y equals to kx over 3 minus k over 3. Right? Kx over 3 and k over 3. Or I can say like this. Maybe it's easier for you to see like this. That's a third kx minus k. That's a third kx minus k, right? A third times by that. I can expand it. That's a third kx minus a third k. Okay, x expanded. I have expanded. That's in the form of y equals to mx plus c. Okay, that's in the form of y equals to mx plus c. So I don't want any solution. I don't want any solution, which means the gradient must be the same. Okay, that's the gradient m1. That's the gradient m2. Okay, the gradient for the first equation and the gradient for the second equation. I can say that's the constant, like the y-intercept c1 and c2. Okay, when it's in the gradient intercept form, the m tells us the gradient and the c value tells us the y-intercept. So k equals to 12. There will be no solution. Okay, there will be no solution when k equals to 12. What I've done, I find the gradient for both equations. I have equalized them, and then I'm solve for k, because that's when the two lines are parallel. Therefore, why we have no solutions. Any questions about this? That's the graphical meaning for simultaneous equation, which is very important. Okay, which is very important. In year 11 and 12, there's a really typical, like, important type of questions, just the series like that. Okay, it depends on that. You will learn that at the start of the year. So that is a very important knowledge. Okay, that's a very important knowledge. Parallel lines will have no intersection. Therefore, for the simultaneous equation, we will have no solution. You need to remember that. Okay, that's about the graphical meaning for the simultaneous. Okay, if you don't have any questions, let's move on to the application. Okay, to the application. A vanilla thick shake is $2 more than a fruit juice. Okay, I don't know the price for vanilla thick shake or a fruit juice. But if 3 vanilla thick shake and 5 fruit juice cost $30, determine the individual price. Okay, remember we have set up linear equations for application questions for a single application, a single linear equation. But for this one, we talk about two things. We have talked about the vanilla thick shake and we have talked about the fruit juice. Okay, we have talked about the fruit juice. So what I can do is let X dollars be the price of vanilla thick shake. Again, I need to define the variable I'm trying to use, and Y dollars be the price of fruit juice. What kind of equation you can write for the first sentence? A vanilla thick shake is $2 more than a fruit juice. What you can write in terms of X and Y? X equals to y plus 2, right? So fruit juice at 2 will be the price for vanilla milkshake. What you can write for the second sentence? 3 vanilla milkshake and 5 fruit juice cost 30. 3x plus 5y equals to 30. Okay, 5 vanilla milkshake is 3 vanilla milkshake is 3x, and then 5 fruit juice is 5y, and that equals to 30 is the total cost. Well, I can choose my own way to solve for it. Substitution and elimination, I think, is easier in this case. Substitution. Well, I say that's equation 1 and that's equation 2. I can sub equation 1 into equation 2. So x is in terms of y now. So 3y plus 2 plus 5y equals to 30. Okay, replace x by y plus 2. Remember to put bracket. Okay, remember to put bracket. So 3y plus 6 plus 5y equals to 30. 8y equals to 24. Y equals to 3. So x equals to 5. Okay, 3 plus 2, x equals to 5. You need to answer vanilla milkshake is $5. Fruit juice is $3. You need to answer the question. Okay, you need to answer the question. Vanilla milkshake is 5 and fruit juice is 3. So fruit juice is 3. That's how we solve for application question by using simultaneous equation. Let's just do one last example here. Okay, I will give the next question as you to think about it over today, and then we talk about that tomorrow. It's a really good question. Let's do example 3. That's a easy one. So 2 Asian armies are 1 kilometer apart. Okay, let's say that's 1 kilometer apart. They're working towards each other. Okay, one walk at a pace of 3 kilometers per hour. So say that the army is towards that way is 3 kilometers per hour. And the other one works at a pace of 4 kilometers per hour. So this is the M. Okay, M work towards that way with 4 kilometers per hour. How long will they work for before the battle begins? I think you don't need to solve for. I just think you don't need to use simultaneous equations to solve for it. You can get the time directly. How long do you think it will take you to work to meet each other? Well, how long they will work before the battle begins? Okay, before the battle begins. Well, you can only begin the battle when they meet each other, right? When they really meet each other. So, how long do you think they will meet each other? Okay, will they work for the same amount of time? When they meet each other, will they work for the same amount of time? If you work there from that way, I run from this way. When we meet, do we take the same time? Yeah, we take the same time, right? So time, not the distance. You will walk from for this different distance.
How long versus the walk was?
Yeah, like, can you help me just walk there? Okay, let's do this experiment. Walk really slow, okay? Okay, walk really slow. Let's say stop. Is that the same time for her and me?
Oh, to meet, yeah.
Yeah, to meet. Like I'm running from there. I'm a different distance, but we take the same amount of time to meet each other. Okay? We take the same amount of time to meet each other. So the time will be the same. Let's say they took X hour to meet. And thank you for your help, Jennifer. Good experiment. Take X hours to meet. Okay, we took X hours to meet. What's the total distance they covered? 1 kilometer, right? Like total distance they covered. Like, yeah, they meet each other, but for example, I can walk for 600 meters and the other army walk for 400 meters. Total, like for same experiment, like
in total. Okay.
I cover that and then she covered this much. The total distance we covered is from there to there. Okay, so they will meet not in the middle because one walk faster. So approximately say they will meet here. Okay, approximately say they will meet here. What's the distance for this army? What's the distance they covered for this army? What's the distance? X is the time. 3 is the speed. 3x is the distance. Okay, that's a 3x. What's the distance the other army covered? 4x, right? So 3x plus 4x will equals to what? Yeah, it will equals to 7x. But what's the distance they actually covered? You are right. That's nothing wrong. It is 7x. 1, right? Oh, good. It's 7x. Well, yeah, like explicit answer should be 7x, but it also is the distance they actually covered. Is 1. Yeah, yes. Okay, 7x is 1. So that's the total distance we covered. And then x equals to 1/7. What is x? Well, I know like what means 1/7 means what? Is the time. Okay, it's the time. So they will walk 1/7 hour before the battle. They will walk 1/7 hour before the battle. It's not a hard question, but I think it's a fun question, like to do in the end. Yeah, fun question. Okay, any questions about this now? Okay. If no, I want you to use the rest of time to try example 4. Well, if you don't have time to try this period, you can try it like after school. But get some idea on this question. Okay, we will talk about that tomorrow. We'll talk about that tomorrow. Stop my recording here.